I videotape you.
Yes.
Thank you.
I have lost track of how many we have.
I am so...
We'll use some.
I think it might break your record.
I don't know. I might get in.
What's the record?
11.
Yeah. I don't know if I have
Enough juice in
enough
there?
of them. Yeah. You can definitely get everything that's in that bag in there, though. Okay. Oops. We'll put him in there. Okay. So, 1,
Oh, sweet
2,
baby.
3, 4, 5, 6.
Oh, that's awesome.
7, 8, 9, 10, 11, 12, 13, 14.
Are they cold right now?
You can touch them. You can hold it if you want it.
Can I? Ah! Yay!
Okay. We got 14 in.
Ah! Sorry, I wasn't ready. That was suddenly cold. There's still some
Barely your spaz.
some liquid in there.
Notice when you put your hands on it, notice that it expands a lot quicker. So
Because of the
they
heat.
can pop, because if your heat's going to it quick enough, it can pop. But
Cool.
So it's still kind of going a little bit. This guy is like slowing. This one's a little bigger.
I tried.
All right. So whose
Can I
law
see
is
that?
this? Charles's law. This is a flexible container, so as the temperature went down, the particles came closer together, so the volume goes down. We take them back out, you see it go really quick, so we can do it again really quickly.
Wait, what did you just say? The temperature goes down to the...
Temperature's going down, so what's going to happen to the particles? They're going to get closer together and take up less space, because this is a flexible container. One of the questions you guys were missing a lot was on the rigid container versus flexible.
Okay.
Rigid means it's not going to be able to go like that. It's rigid. The volume stays the same. This is flexible, so the volume can change. So if I take it back out, careful by the end. He's not a rigid container, so as it heats back up, the particles are going to heat up. They're going to move faster. They're going to expand out. So as it expands back out, it's going to show the volume going up directly with the temperature going up. So this is like what happens to basketballs and soccer balls if you leave them outside overnight and then the next day you go to get them and they go down. That's why. It's also why you notice as it heats back up, they'll go back up, so you don't need to fill them up. You fill them up and then it heats up. You've created too much pressure and it will blow like my jogging stroller did when my husband blew the tire back up on it, and then we went out and went in 100-degree weather and the tire blew completely off the side of the stroller. So that's why you don't do that. All right, so that's an example of Charles's law. So like I said, and I don't want to see everybody do that, but that's one that you could use. That's probably one of the better ones to see of Charles's law, how the temperature affects the volume. Okay, so, and then I don't know if you guys saw this. If you got flip-flops on, kind of watch what you're doing. If you guys saw this stuff roll.
Yeah. Those are used for like warts and stuff.
For what?
Warts or whatever. What do they use for warts?
They use this for
That's what I
warts.
thought.
Yep.